Okay, so we've talked about basic descriptive statistics, and some plots, and we're going to use the skills that we just learned on a dataset that I have chosen to use to run the course of this class to show how to apply various methods on this dataset. This is the police shooting dataset collected by Washington Post. They have one person there reading all the newspapers in their databases to find reports on police shooting incidents. Because there is not a national database to comprehensively collect such incidents, so the journal actually, Washington Post actually do it manually. So this person sitting there and reading those reports and select relevant information from the reports and compiled this dataset. You can find the dataset through this link and read through the dataset description. So it tells you what each attributes are. The reason I chose this dataset not now, we've been running this dataset a number of years. I just felt like we have heard news stories, probably discussed related issues in class, but there are little data to back up a lot of things. And I wanted to, even though this dataset is definitely not complete, it does not show the entire picture. Even what, for example, what the reason the police was called to a certain event was not even reported in this dataset. However, it does give us some data to work with, and it actually covers different data types that we can actually use to demonstrate all the methods that we're going to study in this class. So start today, we're going to look at our police shooting dataset. All set numbers, and but we don't know the details of every incident. Still, I think we should just try to keep objective. All the races has been impact. As you can see, every race, every city, every state have police shooting death. So fatal shooting caused by police. I'm not against the police. I'm just having this data set. I think it's interesting to run it. So if you have not used R for a long time, maybe you can use this command to update R. I did my updates. So we get the data from this link, and instead of loading all sets of different packages, if you just load install Teddyverse, you will have all the packages listed above. So it's much more convenient just to say install package library. Check out this library. I did all that already, so I don't need to repeat that. So the first step, I have the CVS file downloaded from a Washington Post website. I have column names. For NAs, NA were empty cells in the CSV file. So I give those information to read CVS command, and the read CVS will read our data into this variable shooting original. Later on, I'm going to have different copies of the shooting data for different analysis. So I named my current dataset shooting original. So run this. The command runs. It tells us that we have loaded the columns. So I think the system automatically guess what each column data type is. I think ID column is a double. It is not, but it's okay. We can certainly fix that. Name is character and date of the shooting incident. manner of death, armed, whether the victim was armed at the time was the shooting, age of the victim, gender of the victim, race, city where the incident happened, state, sign of mental illness. This is a logical value, true or false. Threat level, whether the individual was attacking police or not. Flee, at the time of the shooting, whether the person was fleeing or it was not, or flee in which way. Body camera, whether the police was wearing body camera at the time of the incident. So this is the data set, and you can see we have date, we have numerical, we have Boolean, and we have lots of character. Those would be nominal characters. Later on you can see that we actually can create, I think, some ordinal data too from the data set that we already have. Okay, so I have the data set now in R. I'm going to set my working directory. When we're working on a data set, it's a good practice for us to work on it and save it. And next time we create multiple copies with different versions, and we save all the data sets, variations of data sets in one location. So that's our working directory. So for this project, for police shooting, I created a local directory on my local computer. I'm going to save this original in this file in this location. Okay, so I set current working directory, and then I save this data set into this file in my local file. Okay, so it's saved. Now I want to know read CSV. Yes, it reads the data in, but what data structure does it read our data in? So I use type of to find out. It tells me, okay, the shooting original is a list. Good. What kind of list? So I further test whether it's a data frame. It says yes. Okay, happy. It's meant to be a data frame, right? Because we have a spreadsheet. This is whether I'm testing whether it's a table, and it is. Okay, good. So we know that to read CSV file actually read a table for you, okay, which is good. Now we want to look what the data really looks like. So we can use either of the command. View will bring up a new window that you can see. So it's a spreadsheet with lots of information in it. The total number of incidents in this, I think it's over 4,000. So we can see name and all that on the columns. And we can also use another way. If we don't want to open a new window, we can use head. Head gives you a little glimpse of the data. It gives you all the columns, but only the first 6 rows. So you can actually have a glimpse what kind of data we have. You can also, I like use string a lot. This string gave you a summary of the data types and all that, putting it together. So using string, we have the output looks like this. So ID is a number. It has from row 1 to 4,478, and the ID was numbers, and name, and date. Other character, other attributes. So that's one way that we can look at it. Another way to look at the overall summary of the data is to use the command summary. The method summary give you, for numerical data, it gave you 5-number summary. For character data, it gave you how many records there is. So when we look at this, we know that ID, the system was treating it as a double. So it's a number, therefore it computes the 5-number summary. That doesn't make sense, and you can just ignore it. We have the name. We have total of those number of those names. It's counting name, not unique name. Okay, so all the names, all the rows there is. So mode here is not the most often occurred value in this attribute name. It's actually talking about the type of the data. So this is again character. Date, class, and mode has slightly different meaning, but for the purpose of this class, you can think they're very similar. So what type of the data there is. So date, so we have the date, what's the oldest, the most recent, the median date, manner of death, and we can look at age is the 5-number summary, and we notice that median and mean are different. That gave us a little bit different, suggesting that the data might be a little bit of skewed. Okay, so that's the summary. Now we notice that the age was a little bit skewed. Maybe we want to look more into the age. So first we compute the mean. The 5-number summary already gave us the mean, but I just want to show you how to compute mean. NA remove means if a value is missing in the age column, then we don't count that when we compute the mean. So remove NA is true. Similarly, we use remove a true parameter to compute the median, and we know median is a little bit smaller than the mean. And then we can use 5-number summaries, but before we do that, I want to show you how to use table. It's a very convenient way to do counts. So I'll first use table embedded in sort, and then I'll show you just use table. So here what it tells us, it tells us that well, I think that's a bad idea. First we should do table, it will be easier to explain. So let's just first do the table. Table basically count the occurrences for you. So we see age 6 have 2 incidents. So 2 victims has age 2. 1 victim is age 12. 1 victim was 13 years old. So this gave us the counting of the individual unique values in age. And then because all the counts are not sorted in order, it's sorted by the age. So the oldest person that we can see was 91 years old. Wow, that's pretty old. Yeah, I'm not sure why police want to shoot a 91 years old, but as we know, we don't have the details, we just have the numbers. This gave us questions. If I had time, I would go and try to trace down that story and understand what happened. Then if we use the sort command to sort what we get here, we will the data are going to be sorted on counts. So now we can see the mode of this data set is 25. 25 occurred. So most people in this data set were 25 years old. We have 163 occurrences. Of a 25 years old being shot. Okay, yeah. So now we can use summary to find the 5-number summary. This is exactly the same thing that we get from this summary. Now we just add this specific column. We're looking at this age. We get exactly the same result. We notice there are 169 cases reports that did not have age in it, did not record the age missing values. And now we can also compute the variance. So variance sample, again, remove the missing values. Oh, sorry. Well, when I was just issued the command of var itself, it gave us the source code of this function. That's not what I wanted to do. What I wanted to do is ask the system to compute the variance. Okay, so now we have mean, median, and 5-number summaries. I want to check the skewness of the age. Um, it looks like younger people are more often to be the victims, but I want to see visually how badly the data is skewed. So if I do a box plot, see how simple it is. Just box plot and age, right? So this gave us a very nice looking. Oh, I know. Hold on, I need to fix something to make it bigger because I have going to try to do this. Nope, that's not the right way to do it. Okay, I've fixed this screen layout problem. So here, we have this box plot. What we see here, we have immediately we have lots of outliers. People older than maybe 70 years old are outliers because vast majority of the people are younger. And we see that this box are not equally divided. The younger, this one is shorter, but it covers same number of observations as the top part. Therefore, we know this part is more dense than this part. So the data, as we see, is skewed slightly towards so it's skewed right or positively skewed. So we have a long tail at the older age. Majority of the incidents happened on younger people. So see, by exploring our data set, we already get some useful information. And now we can, so we talked about QQ plot, quantile plot. This quantile norm plot our shooting our age data against normal distribution. So if we run this, we can see if, so as we discussed in class, if this line is straight, then we know that our data is normally distributed, but we see a fairly clear curve here. So the data is close to, but not really normally distributed because it's skewed more towards younger people that we already know. We can also more intuitively look at the histogram. Remember histogram, we can have density, so those are the percentage of the occurrences, or counts as the y-axis, and the x-axis should be numerical variables. So here we don't have gap. See, we don't have gap, right? So so we can see this visually tells us the data is positively skewed. Okay, so that's histogram that we have created. Now we can look at some other attributes. I want to know how many states has shooting incidents. So I use the unique command to see how many unique states is in this data set. It's represented in this data set. When we do that, you will see all 50 states have had incidents. And we can also use the unique command to check every other variables. But to do that, we have to run unique 14 times. R provides you better ways to do those repetitive work. And here we can use apply. Apply allows you to apply a method unique to either the rows or the columns of a data frame. So 2 indicates that we're going to apply unique to columns. If we use 1 here, we're going to apply unique to the rows. Now we wanted to check for each column, so each attributes, state, city, date, and name, flee, wear camera or not. So for every of those columns that we want to run unique command. So let's do that. So now we can see body camera attribute only have two values, false and true. That was Boolean. It's binary, so we know that. Flee had 1, 2, 3, 4 values and also have missing data. So people may not be fleeing using car flee on foot, using some other way flee. Threat level, whether they were attacking or not attacking or undetermined. Sign of mental illness state, we already did that. And here, I think on the cities, lots of cities are covered. And here are the weapons, whether the victim was armed and what they were armed with. So we can see many different things, 85 unique values. That will be too many for our future analysis. So we will have to do something later to organize this armed attributes better. So teaser, metal object, crossbow, shovel, hammer, gun are all part of the weapon involved in this shooting incident. Okay. So if we want to again see how many cases of flee that we have, remember we used this table before. This gave us counts, right? If we divide every count by the total, the sum, then we will be able to find the distribution in of the values, individual values in the flee attribute. So let's do that. We will see that 67% of the incidents, the victim was not fleeing. And in the rest of the other cases, about 33 cases that they, no, this is a bit 30 cases, 30% of the other cases that they were fleeing, and some other thing, not sure other, maybe by other means, or for that we need to look into the documentation of the data set to understand. But we know 2/3 of the cases that the victims was not fleeing. Maybe they were confronting the police. Who knows? We don't know. We need to check yeah. So that's the incompleteness of the data set that we have. So now earlier we noticed there's missing data, so therefore we want to have an idea how many data were missing. If every case has some sort of missing data, then we're going to have a big problem. So we want to find out how many missing data there is. I'm going to use the filter command. So what does filter do? So first we need to use this command to find out for each every observation whether that data is complete or not. So when we run this, we'll see true and false values being generated for each every observation. So each every incident, whether there's missing data. So if there's missing data, then it's going to be false because the data is not complete. So we're doing complete case, right? Adding the Boolean not here, all the trues going to become false and all the false going to become true. And then filter going to take out all those values that's true. So if we run filter, you will see it will output all the observations having at least one missing data in one of the dimensions or the attributes. Okay, so we have 815 cases with missing value. It's quite significant because we totally, how many rows do we have? We can use n rows to find out. We have 4,478 cases, and among them, let's see, 1/5 of the data have missing value. In the next chapter, when we talk about that data pre-processing steps, we're going to discuss some ways that we can work with missing value, whether we need to remove it or whether we need to fill the missing value. Now, I want to further see which column, which of the attribute has most missing values. So what I do here is again to use this apply function that we saw earlier. And now we need to define, I don't have a ready function to use, so I need to define my own function, which is quite simple. It's just a count. Remember 2 indicates column. For each column, I want to count how many is NA. So missing. NA means not available, missing. Okay. And because the Boolean true is actually considered 1, if we sum up those ones, we will know how many cases in that column has missing value. Once we get this, and we will output what we received from this function to the sort function. So this is a pipe, right? So whatever returned from the previous function will become input to the sort function. So basically, we want to sort the data in decreasing order. So running this, we will get, for each column, we have how many cases have missing values. We see most values missing are in the race column, and then next in the armed, next in the flea, age. So those are the four race, arm, flea, age are the 4 attributes or features, columns that we have most missing data. Okay, so we put that in the back of our mind and continuing explore. The next question, I was interested in which state or the city have the most shooting incidents. Again, we use table combined with sort to get which state. California has the most shooting case. Okay, well, they are most populated too. Then we can use a different way using count method. Do similar things. Instead, this time I'm going to count which city has the most shooting case. Do that. Ooh, Los Angeles, not surprising, right? But then Phoenix is the same. Phoenix and Los Angeles has the most shooting case in that past 5 years that's covered by this data set. Oh gosh, okay. We can explore more and find a little bit more information. So more plots. Yeah, race certainly is on most on the mind of many people here at this time, and probably for a long time. So let's run this. So I'm using ggplot. Well, ggplot is very powerful, but also very complex. We will start by using some of the simple things. We're going to learn those by using those. I don't expect you to memorize how to use it. When I need to use ggplot, I always Google. So for more complex cases, oh, again, I did that, sorry. So the first plot I want to generate is really just look at the race. So race is what? It's a categorical attribute, right? It's nominal. Therefore, we will create a bar chart, okay? And the bar chart going to have a title. The idea of ggplot is to layer up. So first we tell it we want to use this data set, and we tell it what type of graph we want to draw. And using those plus signs, we can add more layer, adding more attributes, so that it gives you lots of flexibility and you can develop really fancy, very highly complex, but also intuitive plots. But here we only name the data set and what's the x-axis, x-axis, and what's the graph type and the title that we want. Okay, so we will run that. And then look at this plot one. We'll run that. So, well, it give us this number. Let's see. What we see immediately, white people, most vast majority of the shooting incidents involve white people. And then second is black, followed by Hispanic quite closely. NA is the missing value, so right now we don't care about it. We notice that Asian, Native American, and other have smaller number of incidents. So looking at this, I think immediately come to our mind, what's the general population's race distribution? So I went out, so as I suggested in our lecture, a lot of times the data sets does not provide you the full picture. You need to go out and find relevant information to help you to understand. So I went to the US Census website and found 2019 estimates of race distribution. And I created a new data frame. So I have in this data frame, proportionally to what the census data tell me, data tell me there's 5.9 of total population are Asian, 13.4 are Black. So based on this data, I generated a little data frame. So I repeated Asian 6 times, 5.986, Black 13 times, Hispanic 18 times, 19 times, to generate a data set that match the distribution of the race in the United States. So I create a data frame US, and I plot the second plot, shows the US, exactly the same thing as we did above. Now it's US distribution by race. So we got plot 2, we displayed that. Yeah, we see white are the most people. White people occupies the most, accounts for the most population in US. And then Black seems to be way shorter than what we saw before. Okay, I want to put those two pictures in one canvas. So I'm going to install a package and use this library. And I'm going to see if I put this side by side, what do we see? Okay, looking at this, what does it tell you? It tells me that white people accounts for the most population in the U.S. and it also accounts for the most shooting death. But Asian relative to white seems to have fewer shooting incidents than expected. It should be taller if we think that shooting incident is purely based on population. And we see that Black, although it only counts about 1/5 of the all white population, shooting deaths accounts about half of the white shooting deaths. So white shooting deaths is significantly higher than expected. Hispanic also, we can see it's slightly higher than expected. Hispanic is much lower. Hispanic is relatively a little bit greater than expected. And then Native American, which is this bar, seems to be relatively normal based on population. I'm not suggesting normal is that thing should happen. No, definitely not. It's just a proportionate. It seems to reflect the population. Okay, so those are some basic information. I think the outlier here is black. It's very clearly that black incidents are way more than expected based on the population distribution in the population. So shooting, and now I can actually plot more. Similar idea that you can actually modify those and try to plot for other attributes. And we know California is the worst one, and then Texas, and somewhere here is Arizona. Um, and so one step further, we can actually add so here fill means the color. So we fill by state, we color by state. That gives us a graph like this. But if we fill by race, change that, we can bring the race factors into this graph. So here we can see for every state our color changed. We used race to for each race we assign it a unique color. And this will allow us to see in every state how the race distribution in the shooting incidents. What we see, I think, fairly clearly that Hispanic incidents occurs most often in those two states. Gosh, and here it's hard for us to see, right? Okay, so we need to make the X tick more readable. So I Googled it and I found code that I could use to modify my ggplot. We can run this and now it's much more readable. We can see that this is California, this is Texas. So in those two states, Hispanic shooting is very prominent. So this is what we can do, and we can do more in terms of getting to know your data. You can look at distributions of by state, by gender, by race, and you can actually get more information in one picture. We in this week's R exercise, you can just see how to use facets to create graphs or plots that involves 3 or 4 factors. So you should practice those. Next class, we're going to actually continue on working on the police shooting data and see what else we can do to prepare our data for our future data mining practices. Okay, I'm going to